That number on your screen right now, 24 billion kilometers, is how far Voyager 1 is from Earth at this exact moment. And it is still, right now, sending us a signal. That signal travels at the speed of light, and it still takes 22 hours to reach Earth. We launched Voyager 1 in 1977, before most of your parents finished school. It has been flying every single second of every single day for 47 years. And it has never stopped talking to us. But here's what nobody is talking about. There is a moment coming, a moment that NASA's own engineers have calculated, when that signal will stop. Not dramatically, not with a warning. The signal will simply become too weak to detect, and then there will be silence. In this video, I'm going to tell you exactly what that moment will look like, what the final transmission will contain, and why, when I researched this, it genuinely stopped me. Because it's not just about a spacecraft, it's about what it means to be the kind of species that builds something like this. In September 1977, NASA launched a spacecraft the size of a small car. It weighed 722 kilograms. It carried 16 scientific instruments. It ran on plutonium power, nuclear batteries designed to last decades. Its original mission was to study Jupiter and Saturn, 2 planets, a 5-year mission. But Voyager kept going. Engineers realized the trajectory was perfect. If they used each planet's gravity as a slingshot, Voyager could keep accelerating outward, into the outer solar system, and eventually, beyond it. Nobody in 1977 planned for what Voyager 1 would become. Voyager 1 flew past Jupiter in 1979, past Saturn in 1980, gave us our first close images of those planets' moons. Then it kept going. In 2012, 35 years after launch, Voyager 1 crossed the heliopause, the boundary where the Sun's influence ends and interstellar space begins. It became the first human-made object to ever leave our solar system. Let that land, something we built with 1970s technology, before personal computers existed, physically crossed the edge of our solar system. In 2024, 47 years after launch, something went wrong. Voyager's flight data system started sending back corrupted data. Gibberish. Engineers couldn't read the telemetry. So they sent a command, a software patch, a fix. And then they waited. 22 hours for the command to reach Voyager. 22 hours for the response to come back. 44 hours total, just to find out if it worked. It worked. NASA engineers remotely repaired a spacecraft 24 billion kilometers away, using a radio signal traveling at the speed of light. This is one of the quietly most extraordinary things humans have ever done, and almost nobody talked about it. Voyager 1 communicates with Earth through NASA's Deep Space Network, a system of giant radio dishes in California, Spain, and Australia. The signal Voyager sends is incredibly weak. By the time it reaches Earth, after 22 hours of travel, it is 20 billion times weaker than a watch battery. Think about that. A signal 20 billion times weaker than a watch battery, and we can still hear it. Only because we built 70-meter dish antennas specifically designed to catch it. The transmission rate, how much data Voyager can send, is about 160 bits per second. Your phone downloads at roughly 100 million bits per second. Voyager sends 160. And yet, every bit of data it sends is precious, because there is nowhere else in the universe that has ever sent us data from this far away. Voyager 1 is powered by 3 radioisotope thermoelectric generators, RTGs, nuclear batteries. They convert heat from the radioactive decay of plutonium-238 into electricity. In 1977, they generated about 470 watts of power, enough to power a few light bulbs. Today, 47 years of decay later, they generate around 50 watts, less than the light in your bathroom. And the power is declining at about 4 watts per year. NASA engineers have been systematically turning off instruments and heaters on Voyager for years, conserving every watt, keeping only the essential systems running. But mathematics doesn't negotiate. NASA's engineers have calculated, with the precision that launched Voyager into interstellar space, the approximate window. Somewhere in the late 2020s, there will come a point where Voyager 1 cannot generate enough power to run its transmitter and keep itself from freezing. Engineers will have a choice: turn off the last heater and extend the mission slightly, or preserve the transmitter as long as possible. Either way, the signal will eventually become too weak to detect. And then, for the first time in nearly 50 years, Voyager 1 will go silent. Here is something nobody has properly explained. The final transmission from Voyager 1 will not be dramatic. It will not be designed as a farewell. It will just be data. The same engineering telemetry it has been sending for 47 years. Power levels, temperature readings, instrument status. Numbers, declining numbers. And at some point, those numbers will drop below the threshold where our dishes can reliably detect them. The signal won't stop. Voyager will keep transmitting into the void. We just won't be able to hear it anymore. There will be no last word, no final image, no goodbye. Just fading, and then silence. But Voyager 1 carries something that will outlast the signal. That will outlast us. The golden record? A 12-inch gold-plated copper disc, attached to the spacecraft. On it, 116 images of Earth, sounds of our planet, wind, rain, surf, thunder, music from 27 different cultures, greetings in 55 human languages. Carl Sagan, who helped design it, called it a message in a bottle cast into the cosmic ocean. The golden record was not built to be found. The engineers knew the probability of an alien civilization intercepting Voyager was essentially zero in any human time frame. It was built because of what it said about us. Before Voyager 1 left the inner solar system permanently, in 1990, Carl Sagan asked NASA to turn the camera around, to take one last photograph of home. What Voyager captured was a photograph of Earth from 6 billion kilometers away. Our planet. In that image, a pale blue dot, less than a pixel, suspended in a shaft of sunlight, almost invisible. Sagan wrote about that image in a way that I've never been able to improve on. He said, "Look again at that dot. That's here. That's home. That's us. On it. Everyone you love. Everyone you know. Everyone you've ever heard of. Every human being who ever lived." And the spacecraft that took that photo is still flying, still moving away from that pale blue dot, every second of every day. Now 24 billion kilometers from the dot it photographed. When Voyager 1's signal finally fades, something specific will happen. For the first time in human history, every object humanity has ever built will be within the range of our communications. Voyager 1 will continue flying, silently, for millions of years, long after every human language has changed beyond recognition, long after every civilization we know has risen and fallen. In about 40,000 years, Voyager 1 will make its closest approach to another star system, a star called AC plus 793888. Nobody alive today will know if it gets there, but it will get there. Something we built in 1977 with slide rules and early computers will pass within 1.6 light-years of another star, long after the species that built it has changed beyond recognition. I want to ask you something that I've been sitting with since I started researching this. When Voyager's signal finally goes silent, what do you think humanity should do? Do we launch Voyager 3, a new spacecraft with modern technology, carrying a new message? Do we accept the silence as a kind of completion? Or do we do something nobody has suggested yet? I don't have a clean answer to this, and I think that's okay. But I genuinely want to know what you think, because the comments on these videos are sometimes smarter than the videos themselves. Tell me below. I read every single one. One last thing. The Golden Record, that disk attached to Voyager, flying silently through interstellar space, contains a map. A map of where Earth is, relative to 14 pulsars, so that any civilization that finds Voyager can find us. Some scientists think this was an incredible act of cosmic courage. Others think it was the most dangerous thing we have ever done. That debate, about whether we should have sent that map, is one of the most fascinating and genuinely unsettling conversations in modern science. And that is exactly what Thursday's video is about. It drops Thursday 6 p.m. Don't miss it.